Okay, today we're going to look at section 1-2 from your textbook, which can be found on the Envision website. And this is called Solving Linear Equations and Inequalities. And so for the first example, we're just going to start out with something that you've done before. So in previous years, you've been introduced to two-step equations. And what you're going to do is the inverse operation to solve for x. So the inverse, some teachers may have called it the opposite, but it's really not the opposite, it's the inverse. But if it's subtracted, we add it to both sides. Okay, so then we'd rewrite it. That would be 10. And then we'd be left with 2x over here. So if 2 is multiplied by x, then we would divide it. So we're going to divide both sides by 2, and we'd be left with x equals 5 is our solution. And if you wanted to check that, which is something that you should do, you'd plug it in to the original equation and just check to see if it's true. So this is 10 minus 3, and 7 equals 7 is a true statement. Therefore, x equals 5. So basically, we're just going to do that same thing while adding a variety of numbers and everything. So if we go to the next one, we have this equation, and we're going to solve for x. So this one looks a lot more complicated, but it's not really. It's just a couple more steps. So I'm going to go to red. So same thing. If you have numbers added or subtracted, what you're going to do is first deal with those. So I would add 8 to both sides. So I'd have 40 on this side. And then I would be left with 2 times x plus 4 divided by 3. And you can do this a number of ways. So we need to, this expression on the right, this is divided by 3. So we would need to multiply both sides by 3 to do this. So I will do that. So I'm going to put this in parentheses. That's important to do. And then I'm going to multiply by 3 on both sides. And so let's do the right side first. 40 times 3 is 120. Now on the left side, I've seen students do all sorts of things. They would multiply 3 times 2 and by x and 4. All you're doing right here, though, if you multiply 3 times a number over 3, like for instance, if I choose a different color, so if I were to multiply 3 times 1/3, and this is kind of an aside, this would give me 3 over 3, which is 1. So what exactly happened right there? Well, these just canceled. So instead of distributing the 3 through all of that, all you're really doing is canceling the 3 like this. So now we have taken care of the 3, and we can move on. So we have 2 times x plus 4 equals 120. Well, this is a much easier equation to deal with. All you do is distribute the 2 to both terms, so 2 times x and 2 times 4. And now we have a two-step equation. So subtract 8. I'm left with 112 equals 2x. And then we just divide by 2. So that would be 56. And similarly, you could check this like we did the previous example. Okay, here's another example. This one is really super similar to the previous one, except for this 4, it's just on the other side. So if it's on the other side, you just do the exact same thing you would do to the other problem. So if you see a number added or subtracted, then you would deal with that first. So we're going to subtract 4 from both sides. So we get 4 here, and then we have this 2x plus 2 over 3. And just like the last problem, that 3 in the denominator, the whole left side is divided by 3, so 2x plus 2 divided by 3. So we need to multiply it by 3 to clear it out. So we're going to put these in parentheses, multiply by 3. And just like the last example, this side is going to be 12. I'm going to move that down actually a little bit. And then the left side, these 3's just cancel. Don't distribute them because then you're going to create a lot of work that you have to undo anyway. So then you have 2x plus 2. We're down to a very simple two-step equation. So subtract 2, get 10 equals 2x. And it just so happens the answer to this one is also 5, like that first example. So those are very straightforward problems. And they don't get too much more complicated than that in this section anyway. Okay, in this example, it's a lot like one of the previous ones we've done. It's really a two-step equation, which you have done last year. So we add 2 to both sides to make it 6 on the right, and then we would be left with 3x over 4 on the left. And I'm going to highlight one important thing. If you have 3x over 4, that is the same thing as 3/4 x. But that is not the same thing as 3 over 4x. And I will be highlighting stuff like that a lot because those are common mistakes. If we go back to this, we could multiply both sides by 4, then divide by 3, but I like to do this in one step. So let's multiply by the reciprocal. And the reciprocal is just the same fraction flipped around. So these would cancel, 3's would cancel, and so you'd be left with x, and this would be 24 over 3, or 8. Okay, so here's one slightly more complicated, but really not too bad. So I'm going to choose a red. You have to find a common denominator before you do anything with this one. So what is a denominator that would be common to 2, 4, and 8? Is there an easy way to make 2 an 8? Is there an easy way to multiply 4 by something to make it an 8? That's always the question with this. And on the first part here, 2 times 4 is 8, so that was easy. And then 4 times 2 is 8. So we've now found a common denominator, it's 8. And so I'm going to simplify this. So this would be 12x minus 2x over 8 equals 7/8. And so I can simplify that further. 12x minus 2x is 10x over 8 equals 7/8. So we could, let's use that reciprocal idea again, because we just did it on the last problem. Let's multiply both of these by 8/10. So on the left, these cancel. We're left with x. On the right, your 8's cancel, and you're just left with 7/10. So 7/10 is our solution there.